Hello, welcome to our introduction video into the electronic conference on geoengineering and lakes. My name is Brian Spears. I'm a freshwater ecologist from the Centre for Ecology and Hydrology in Edinburgh. For the last few years I've been working on lake restoration projects, and specifically in the last year or so I've been working on whole lake experiments and various lab experiments to look at the use of geoengineering products for phosphorus control in lakes. And over that time we've travelled to various conferences and probably spoken to many of you who are watching this video, and we've seen some common questions arise on our discussions of this research topic. And so we thought it would be a good idea to try and hold an electronic conference so that experts in the field and people who are just interested in the field can come together and have some discussion on the state of the art in the research field. And the reason that this is important is because our research is being used by policymakers and water managers as an evidence base with which the approach is being considered for use in many lakes across the world. So really I just wanted to introduce the e-conference in this video and then hand over to the session chairs to take it further. So why restore fresh waters? Well, water security is a major concern of governments, industry and citizens. Our freshwater systems deliver services of high economic value, and there's research projects ongoing just now, especially in the EU and I'm sure in other countries, to try and come up with methods of valuing that in economic terms. But our lakes and reservoirs and rivers are important for water supply, for the drinking and industrial supply and agriculture. It's important for energy production, for recreation and tourism, for water purification and for food supply. So obviously anything that we do to try and manage and improve or enhance the delivery of these services is important to lots of different people. And so it's also important that we try and understand what the target consequences and the unintended consequences are of new management measures as they come online. And that's really this conference is all about, looking at geoengineering within that context. So phosphorus pollution is a global problem that is really costly to control. Phosphorus, once it enters our lakes, can result in the proliferation of algal blooms, and here are some images on this slide that have been given to me from various colleagues working in this area, where we can see that people really come into contact with algal blooms, and here we're looking at cyanobacteria blooms, which can produce toxins that pose a human health risk. So with regards to the cost of management, estimates in 2003, so really before the big EU policy kicked in, the Water Framework Directive kicked in, which now requires management measures to be put in place by 2015 or 2027. The cost estimates for management were about 180 million euros per year for management and policy costs, and similarly in the US estimates were about 1.5 billion euros per year, that estimate from 2009. So the scale of the problem is quite large, and when we look at some risk assessments of lakes that are likely to fail our water policy targets for total phosphorus in the UK, the scale is even more shocking, where we see the numbers in England about 72% at risk, Wales 34%, Scotland 23%, and across the EU as a whole on average about 40% at risk. And so in all of these lakes, our Water Framework Directive in the EU would require us to implement management measures to improve them. So some form of phosphorus management would be required in a large proportion of these lakes to meet our water quality targets. And similar scenarios are true in the rest of the world. Certainly the Clean Water Act in the USA is a good example of that. So when we restore our lakes, we have lots of benefits. We can improve the raw water resource for many activities, for example, for the reduce treatment costs for drinking water, to improve and enhance our natural capital for recreation and tourism, and also specifically to enhance the habitat for some of our iconic species. And so managing these pressures on our lakes is really quite important for lots of different things. One of the issues is that our ecosystems don't recover very quickly. This is some work that was published by Helen Jarvie recently, where estimates of recovery time for following catchment phosphorus management were estimated for lots of different aquatic systems. And so lakes are down at the bottom, and for those of us who have been working in lakes for a few years, we know our lakes recover very slowly. Here estimates from the literature of between 5 and 30 years recovery time after the tap of phosphorus from the catchment has been switched off. And really the drivers of that long recovery time are interactions of between the sediment and the water column with regards to phosphorus cycling, and this is a term that's really been coined recently as legacy phosphorus. And so even if we reduce the catchment phosphorus sources to lakes, they're unlikely to recover by the policy deadlines. So for the Water Framework Directive, as I said earlier, deadlines of 2015 to 2027. So there's a need to develop means of speeding up recovery, and that's really where geoengineering products why geoengineering products have been developed in recent years. Here are just some photographs of some of the many applications that have been trialled. Here we can see application directly to lakes from helicopter. This photographs taken in New Zealand, and also the treatment of inflowing phosphorus using iron chloride. In this case, was a photograph taken from Finland. So there are lots of new products being developed. It's an interesting market for eco-innovation or green industry. And because of that, it's really quite difficult for the research community to get a handle on the quality of these products and the chemical composition and the ecotox impacts when they're applied to lake, and dosing, and lots of different issues related to operational performance of the product. And so there's a real need to try and pull the information and the expertise that's held across many different countries and many different institutes and many different researchers to try and present that information in a way that water managers and policymakers and industry themselves can digest and act upon. So at the large scale, when we look at potential costs of geoengineering with regards to resources, both in terms of economic and in terms of mineral resources, we can see that the scale of this issue is quite vast. So we're not proposing here that geoengineering be used to restore every lake, but just to put it into context, when we consider lakes in the EU, estimates of about 31,819 square kilometres of lake surface area needing to be restored, a large proportion of which will be failing Water Framework Directive targets as a result of phosphorus pollution. We can look at the estimates of cost with regards to the application of common products, and here we're looking at the application of Phoslock, which is a lanthanum modified bentonite product which is designed to be applied to lakes for the control of phosphorus release from sediments. And at the top end of this scale, so if we look at around about 40% of the lakes that need to be treated, then the cost in billions of euros is up at about 70 billion euros, with teragrams of Phoslock required around 20 teragrams of lanthanum, just over 1, and teragrams of phosphorus, just over 0.2 teragrams of phosphorus would be removed from the global phosphorus cycle if we applied this product to around 40% of the lakes in the EU. So really large scale issues, and when we start to scale up the question of using geoengineering as a water quality management tool to this scale, you can see that it has some fairly significant implications with regards to both resource availability and the cost of meeting these water quality targets. So important that we get things right the first time round. It's too costly to try and do things time and time again. And so to try and address some of these questions, we've pulled together some of our colleagues from around the world, and their job is really to take one of the key questions that we identified as being important, and to invite plenary speakers on to discuss these key questions, and then to host a discussion. So we've planned the conference to start on the 10th of March in 2014 and run to the 21st of March 2014, and we decided to have 4 key sessions, 2 in week 1 and 2 in week 2. So session 1 would be chaired by Stephen Maberly from the Centre for Ecology and Hydrology in Lancaster, and Stephen's session will be looking at understanding the unintended consequences of geoengineering in lakes. Session 2 will be chaired by Gang Pan from the Chinese Academy of Sciences, and Gang's session will be looking at advances in materials development and application procedures. Session 3 will be chaired by Kasper Reitzel from the University of Southern Denmark, and his session will be looking at assessing future research requirements using evidence from whole lake experiments. And Session 4 will be chaired by Brian Haggard from University of Arkansas, and Brian's session will be looking at the need for decision support systems for practitioners to underpin wide-scale use. So hopefully that's just given you a flavour of the key topics that will be discussed, and as I said, each session will have some plenary speakers that will give more in-depth presentations with much more detail. So the session structure, what we hope to do is, first of all, one of our session chairs will give an introduction video similar to the one I'm giving just now, which will highlight the key questions that they want addressed in their session. And then on day 1 to 4 of the 1 week sessions, we will have a plenary presentation in the morning of each day, and these plenary presentations will be invited and will give further information on one of the key questions that the session chair has identified. Following each of those presentations, there will be a written discussion which will be open, and so everyone can get involved in that discussion, and then that will occur. We'll have a different discussion every day following each of the plenary presentations, and then at the end of the week the chair will summarise these discussions in a short video and really just pull everything back together again. So with regards to the outputs, we thought it was quite important to hold this e-conference so that it was open, so the information could be accessed as widely accessible as possible. But we also acknowledge that we have to target some different audiences. So yes, we'll have a conference web page which will have links to the plenary videos and the session summaries, but we're also targeting a special issue of a journal to highlight the state of the art in the research field. And then finally, we want to bring this all together to prepare a policy brief to communicate the views of the research community to policymakers and also water managers in this field. So that brings the introduction video to the end. Thank you for listening to me. I'm sure all of our session chairs and plenary presenters are going to have as much fun as I've had in learning to use the video conferencing facilities. I would encourage everyone who's watching the video to please get involved in the conference. The link to the conference is on the slide. Please get on there and register your interest, and we hope to hear from you and to hear your views in March 2014. Thank you.